A we did last day, and I showed you that the absolute value function was split into two parts. And I asked you, first of all, to write it as a piecewise function, which we did. Okay, the blue piece, the green piece, right? And then I said convert to the absolute value. Now, I wrote down this as the answer, but technically I wasn't totally honest with you, because this is just one of two possible answers. What other answer could you have written this as? Yes, Darren? Negative 1/2 x plus 2. Technically, I could have used the equation from above, because what happens when I take the negative anyways when I do the absolute value? It becomes a positive. So either or will work. Okay? I just told you last time to use the positive one because I'm a positive kind of guy, right? Positive. Okay? Okay, on the test, if I say to you, can you find all possible absolute value equations, then I would expect both. But if I just said find the absolute value equation, giving me one will be fine. Okay? All right. Let's do part B. Okay, part B. Ladies and gentlemen, I showed you last day, at least with the start, that you can find the x-intercepts to be here, okay, at -1 and 2. And now technically, if you wanted a more accurate answer, I needed to give you at least one more point on this parabola to get an accurate answer. But I didn't give it to you, so my apologies. So I just said to you, why don't you use this as a, as a simplified kind of answer. Okay, remember how if you are given the zeros, you can write it in the bracket form, and then if I ask you to expand this out, which I hope some of you did, you get this. Right? Y equals to x squared minus x minus 2. Yes or no? Okay, good. Now, if you were to write this as a piecewise function first, this is like a review from last day, what would your three pieces be? Well, first of all, let's see what our domain is going to be if I asked you to rewrite this. What about this part here? What's the domain? X is less than or smaller than -1. Good. Now, I hope you realize that this was a parabola that originally looked like that, right? So what's the equation of that parabola? Well, this part, there was no change, so I'm going to leave it as x squared minus x minus 2. Okay? Now, you figure out the rest. How about the part in the middle? Okay. Let's look at the part in the middle. The part in the middle here is, well, that's the part that got reflected. So how do I show something that's reflected using an equation? Put a negative in front. Thank you. So x squared minus x minus 2, put a negative in front. If you don't like that, if you want to distribute, you can rewrite this as negative x squared plus x minus 2. That's perfectly fine. What's my domain in this case? How about the values between -1 and 2? And once again, I just put an equal sign there because the other one did not have an equal sign. Okay. Last piece. Yes, question there? Yes. Oh, you're talking about this stuff here, Alex, right? Okay. That part is not about the reflection. Okay. Those are two separate things. What I'm saying over here after the if statements is I'm trying to describe the domain for which the equation works. Okay? Now, if you look at these two equations, they actually meet at -1. So technically, if I were to plug in -1 into the equation above or the equation below, you'll get the same y value. So it really doesn't matter. Okay, Alex? It doesn't matter if you put it down here or you put it up there. Just don't put it on both, because then it looks kind of confusing. Okay? So similarly, Alex, I could have put an equal sign here, and then for the last piece, I would have just said x is greater than 2. Is that okay? Now, if I didn't want to do that, I could erase the equal sign here, so let's forget that, and then put the equal sign down here. Once again, no big difference. Okay? By the way, that last piece, notice I did not change the graph, so there's no negative. Okay? So, ladies and gentlemen, what's the final answer here? If I want you to convert this to absolute value, it's y equals 2, and if you wrote this down, you would have been correct. Now, is this the only answer? No. What's the other answer then? The negative one, right? So negative x squared plus x plus 2. Now, technically with the negative one, my original graph was not the one in red, but my original graph would have looked like this. And I'll do it in blue. My original graph would have been like this, right? Negative x squared, it opens down. But when I take the absolute value of this, what picture do you get? The same thing as what you started with. You see? That's why the absolute value of a positive equation or a negative one, the pictures still look the same. Okay? Any questions about this one? All right. Okay. This one here. I'm not going to do it for you. I want you to think about this yourself. How many of you would do this question if I gave you a prize? What kind of prize? What do you guys always want? Wow. Wait. Stop recording this. I want us to come back to this idea of what absolute value actually is. It's used to represent the distance of a number from 0 in the real number line. So if I asked you to solve this question now, the absolute value of x equals to 6. If you were to use this number line, what would the answers be? You're saying what value of x is 6 units away from 0? You either go 6 to the right, which produces what answer here? 6. Good. So therefore, yeah, x equals to 6. Or what else? Yeah, you could go 6 to the left, right? The distance is still the same. The distance is still 6. But what's this value over here? On the number line, negative 6. So ladies and gentlemen, your two answers for this absolute value equation are x equals to negative 6 and x equals to 6. Now, how can we do this algebraically? Now, before we do things algebraically, I want to show you the picture, because I want you to have a visual representation of what this means. And this is where I'm going to ask you to use your graphing calculator, too, to help you draw out this picture. Okay? Here's an equation. So this is what I'd like you to do on your graphing calculator. Or let's actually not use your graphing calculator yet. Let's even do this by hand first. I'd like you to graph out y equals to the absolute value of x. And I also want you to graph out y equals to 6. Okay? So let's do this without your graphing calculator first. I'll show you that in a second. How would you graph out y equals absolute value of x? That should be pretty straightforward, I hope. V-shaped graph, right? So go ahead and draw it in, please. There we go. There we go. Okay. There's y equals absolute value of x. And then after you've done that, can you please graph out y equals to 6? And I think you've done this stuff before. Grade 10, you have two graphs. How do I find the solutions? What do I look for on the graph? The intersection points. Thank you. So go ahead and graph out y equals to 6. By the way, y equals to 6 is what type of line? It's a line, straight line. Yeah, I know, but which way straight? Horizontal. Thank you. So at y equals to 6, you should graph out the line like this. And like you said, you're looking for the intersection points. Guess what the intersection points are? 6, 6. So therefore, x equals to 6. And then over here, negative 6, 6. Therefore, x equals to negative 6. The same two numbers you got from there. Okay? Now, of course, this is not really algebra. This is just graphing, but I hope you can see the visual picture. Yes, Gavrilo?
There's no question. I don't think it's strictly. It is perfect.
Why are you asking then?
Just curiosity. When you have x cubed.
When you have x cubed, yes.
Okay, just wait for pause.
Oh, wait for pause. Pause. Clear. Okay? So, do you need this? Okay, here we go. Press on. Go to your y equals to screen. Oops, make sure you're in the right mode. I'm in the right mode. Okay? So you're thinking, Mr. Lee, where is this absolute value function? Here it is. There's no button for it. Sorry. So you have to find it. Okay, here you go. Watch, please. You see where this green button is, the alpha button? Underneath is this math button. Press math. So what you do when you press math is you get a whole bunch of different functions. By the way, if you haven't figured this out, your calculator changes decimals and fractions for you. That's what this number means. Arrow frac. Change decimal to fraction. This changes fraction to decimal for you. This is the cube button. This is the cube root button, the nth root button. And then underneath here, 6, 7, 8 are other buttons that you'll use for calculus. Okay, so enjoy that next year. For the absolute value function, you scroll to the right and you get to this number menu. And of course, all men and women want nice abs. That's the absolute value, okay? So if you press enter now, ABS stands for the absolute value function. So if you graph out ABS, put the x next to it, and close the bracket, you have just written down the absolute value of x. Okay. So once again, math, number one, absolute value. Okay. Now, of course, I have two equations here. I also want you to write down y equals to 6. So do that. I'll press zoom and I'll press zoom standard, and let's see what picture you get. Okay. There you go. Okay. And if I asked you to find the intersection points as a quick review, second trace, choose number 5, get close and closer to one of the coordinates, press enter, 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 and there you have it. It's there. So ladies and gentlemen, you have now learned how to solve every single absolute value equation using your graphing calculator, which means that I don't need to actually teach you how to do things by algebra, right? Wrong. And I will take the privilege away of using your graphing calculator on the test, probably, right? Right. Okay. Okay, ladies and gentlemen, this is what I want you to know for today for sure. How in the world do we solve these algebraically? Okay. Shh, quiet please. You think you can solve example number 1? I bet you can right now using the graphing calculator. So let's do that. Let's just do that right now. Oops. Sorry.
Thank you so much.
Sorry. Okay. Y equals 2, and I want the absolute value, but this time I want the absolute value of 2x minus 3. Okay? I hope you can do this. And then underneath, I don't want 6, I want 5. Okay, and I want you to graph this out, and I want you to sketch it on the actual graph I gave you here too. Now, before we do any of this sketching, can someone suggest to me what this value right here at the x-intercept is going to be? 3/2. How'd you get that so fast? Remember, you make that stuff inside equal to 0. It's the x-intercept, so you let that part equals to 0. You solve, so you get x equals to 3/2. That's your breakpoint, or what we call the invariant point. That's what they use in your textbook. That's the point that doesn't change. So right here, 3/2. Okay, and then of course you have your absolute value graph that kind of goes like this way, woo, and this way like this, woo. Okay. Sorry? You could solve for x, it doesn't matter. I'm just trying to show you this graphically first, Rebecca. Then afterwards I'll show you how to do this algebraically. I want you to have a visual picture first.
Is that 1.5?
Okay. This is 1.5 here, yes.
Is the y is it supposed to be on 4 or
I think it's supposed to be on 3. Okay. And then if you were to graph out the line y equals to 5, you get something like this. Okay. And so with your graphing calculator, okay, Mavis, if you're going to do biology, just do biology, okay? Go ahead and do the intersection feature. Enter, enter, enter. Okay, you get -1, 5. And what's the other one going to be? Can someone figure out the other one for me? I'm too lazy to do it. 4, 5. That makes sense. Okay, well, that's good. Okay. So by the way, you already found your answers then, right? What's your solutions here? X equals to -1 or 4. Okay. Now, that's graphically. But guess what? I want to show you this to you algebraically, because you might not have your graphing calculator with you one day, like on April 13th. Okay, so let me show you how we can do this. Do you remember how I told you last day that every absolute value can be split up into piecewise functions? Remember those two pieces? Can someone write that for me then? What are those two pieces? So I'm going to say let's rewrite using piecewise function notation. Okay? Can someone help me out, please? What does this become? Y equals to those two pieces. Help me out, help me out. Okay, there's a negative part? Sure. So negative bracket 2x minus 3. And there's a positive part, right? 2x minus 3. But you need to give me a bit more information. What about the domain and range? Oh, not the domain and range. The domain for the pieces. Which one's which?
Wait, the negative part is.
The negative part is the right side? So I'm confused. I'm just asking,
Wait,
okay?
oh no, it's the left side?
This part here. Which part is it? Is it the left side or the right side? Which one? Good, left. It's the left side. Okay? By the way, how can you tell? Because it's negative, right? If you were to distribute this out, right? Okay, what do you get? You get negative 2x plus 3. Which line? Which part? The downward sloping line part or the upward sloping line part represents that? It's the downward part, right? So this is when x is less than 3 over 2. Okay? Some of you haven't done your homework yet. What about the next part then? Greater or equal to 3 over 2. Okay? I hope this is okay. We did this last day. Okay? Now, how is this supposed to help me out? Well, can you actually see that there are actually two different parts to this absolute value graph? So technically when you solve, you have to solve two different equations. So, here's what I'd like you to understand. You see how you split up the absolute value graph into two parts? Well, guess what? I'd like you to split up this equation into two parts. Let's call case number 1 the part where x is less than 3 halves. Let's call case number 2 the part where x is greater than 3 halves. Okay? Two separate equations. Now, I'm going to copy the question again. If you don't want to do that, that's fine. Okay? But I just want you to see this is what I mean when I look at the two different cases. Okay? Now, right now, let's do the case on the left first. Visually, okay? I'm going to try to connect this visually to the graph. Which part of the graph am I looking at right now? I'm looking at this part right here. Can you see? Can you see? Okay. So which part of the absolute value piecewise function am I using? The blue stuff or the black stuff? Who said blue? Be bold. Who said blue?
Me.
Good. She's correct. Okay? She's correct because, look, I said the domain is less than 3 halves. Well, this is the case. So what I'm saying to you is let's replace the absolute value with negative 2x minus 3. Okay? Go ahead and solve this now. This is just really, really elementary algebra, isn't it? Go ahead, please. Negative 2x plus 3 equals to 5. We'll subtract 3 on both sides. Negative 2x equals to 2. What's x?
Negative 1.
Look at that. Negative 1. Okay? Okay. You go ahead and solve the next side then. What's case number 2? Well, case number 2, we're looking at this side of the picture now. So what would I replace the absolute value with? Yeah, just the regular 2x minus 3, because that's what the equation of the line is. Go ahead and solve. And you get x equals to 4. Your two answers. Done. Okay? Ladies and gentlemen, this is the basic idea of how you solve absolute value equations using algebra. Okay? But once again, I wanted to do the picture for you first so you can see what we're actually doing. In essence, you just said, let's split this grid into two separate parts. How do you split it up? You split it up at that invariant point. And let's go ahead and solve for one piece of the absolute value, then solve for the other piece. You've got your two answers. Okay? So in general, let's take a look and quickly review. What do we do? I said, let's rewrite your absolute value expression in piecewise notation. That's something you need to do first. Okay? Step 2 says, consider each part of the separated domain, which is the different cases, okay? And then you need to replace the absolute value with the appropriate part from the piecewise function. So this step here in number 2, replacing, is what I did up here when I went from there to there. Okay, when I went from there to there. That's the replacing part. Okay? Then what's next? Do all the algebraic calculations for both of the different domains. And then you can solve. And I didn't check my answer, but you could check your answer by plugging it back in and making sure it's correct. Okay? Now, before you turn the page, just let me say one quick thing. Some of you might be thinking, oh my, Mr. Lee, there's so much work here. Okay? Indeed. I'm hoping that when you do enough of this, you can probably, with practice, so I'll say with enough practice, you should be able to skip that first step. Okay, you technically don't need to rewrite the absolute value every single time as piecewise notation if you can visually already see which part is which. Okay, if you can't, of course, I'm going to ask you to do that right now. Okay? Pretty much the main things you need to show is the stuff that I highlighted in both the left and the right part. Okay? In the yellow box and the purple box. Are we good? Okay, let's turn the page now. Go ahead and start the next one on your own. Okay? Let's see if you can try example number 2. Okay? And then I'll do example number 3 with you together. Okay? You try number 2 first of all on your own. Right path. I think the first thing I would have done is try to find this breakpoint, which is 2x minus 7 equals 0. So you solve for this, you get 2x equals 7, x equals 7 over 2. Okay? Then I would have said, let's rewrite this as a piecewise function. There's always a positive piece. There's always a negative piece. Now, once again, the order doesn't matter, but what does matter is the actual domain. Which part's negative? To the left of the breakpoint or to the right of the breakpoint? To the left. Good. Okay. To the right would be the positive portion. Okay. Once again, if you're not too sure why that's the case, and if you want to quickly graph this out, I would have graphed out y equals 2x minus 7. That's this line here. And then, I remember that absolute value means you reflect. So therefore, which part got reflected? Is it the part to the left of the breakpoint or to the right of the breakpoint? Right? The left. So that's why it's left. Yes. Yeah. Okay, so if you got that part, it's time to do the different cases. Case number 1, I'll say that's when x is less than 7 over 2. Case number 2, I'll say that's when x is greater than 7 over 2. Now, ladies and gentlemen, I'm going to skip a step. I told you earlier to rewrite the equation. I'm going to cheat. I'm going to right now replace the absolute value right away. For case 1, what does the absolute value become? I'm a rebel, right. I'm going to replace it with a negative 1 because I'm looking for the case where x is less than 7 over 2. Is that okay? I skipped a step here. Is that okay? Yeah? Okay, let's go ahead and solve this. Expand negative 2x plus 7 equals 1 minus 6x. Go ahead and solve this. Let's see. I'll add 6x to both sides. That's 4x plus 7 equals to 1. Ooh, ugly number. 4x negative 6. Is x equals to negative 6 over 4? Is that what you guys got? Okay, so that simplifies to x equals negative 3 over 2. Okay? That's what you got? Good. Okay, whatever, same thing. Sure. Okay, let's go to case number 2 now. And I hope you did the same thing. In this case, what does the absolute value become? Just the regular 2x minus 7, no change. because this is the part of the graph that didn't change, right? No change here, no change. So that equals to, once again, 1 minus 6x. Let's go ahead and solve this. 8x equals to 8x equals to 1. Done. How many got those answers? How many finished the question? Okay. What did I say to you before on the previous page? Solve and check. How many of you actually checked? Good. So if you checked, what do you answer? This one doesn't work. What? Okay, let's check this one. Shh. Okay. Dear friends, this is important. Let's check. Let's check. If I ask you to check, what I'm saying to you is just plug it back into the original equation. 2, and wherever you see x, replace it with 1 now. Okay? Please do this. This is important. Okay? Remember, this is an equation. So the left side should equal to the right side. 2 minus 7 is negative 5. Oh, the absolute of negative 5 is what's on the left. 1 minus 6 is negative 5. Oh, that's on the right. What's the absolute value of negative 5? 5. Does 5 equal negative 5? No. That's why this answer doesn't make sense. This is extraneous. Okay? Now, you should check the other one, but I decided not to because I'm lazy. How many of you don't like checking at all? Good. Do you know there's another way of doing this without checking to figure out your right answer? Okay, let's think about this. Let's think. Is there some sort of NPV? Restriction? Watch. Watch, watch, watch. I'm going to circle two things. Okay? That's just one thing. I know. Here's the other thing. So for case number 1, you said we're looking only at the graph where x is less than 7 over 2. Is this answer less than 7 over 2? Yeah. It works. Okay, I'm going to circle two more things now. On the right, you said to me, we're looking only at the part of the graph that is greater or equal to 7 over 2. But my answer here is 1? Is 1 bigger than 7 over 2? No. That's why this doesn't work. It's extraneous. Okay? Be careful. Algebra could be deceiving. You need to check. Yes, Megan. Okay, Megan's saying, well, is it more important to figure out that this portion here, 2x minus 7, is bigger or equal to 0? Or this one? Technically, both matter. Okay? Now, what Megan is saying, and you don't really need to do this if you don't want to, but Megan's saying, Mr. Lee, I understand that this whole absolute value here is bigger or equal to 0. Right, Megan? So technically, if you want to write down your restriction, and don't worry, you're not responsible for this, this whole thing here must be bigger or equal to 0. Does everybody understand that? Okay. So because that's bigger than or equal to 0, then negative 6x is greater than or equal to negative 1. Divide, this, you get x must less than or equal to 1 over 6. So technically, this is your restriction for this graph. Okay. Now, you don't necessarily need this. Not needed if you remember always to check. Okay? If you do not want to check, then yes, you should think about your restriction and then go from here. Which one of those two answers is less than 1/6? Of course, it's the one that is negative 3/2. Okay? Tricky, isn't it? Ooh. Try example 3. Go ahead. This one might be a trick question too, so think about this. And if you want to double check your answers, graph it out with a graphing calculator. I'll give you a few minutes to think about this one too. And if you're done this one, or be very, very mad at me, either way, you're learning, so that's great. What's the break point, by the way? Let's do that first, or the invariant point. Good, that's just 3, right? 3 minus x equals 0, x equals to 3. Good. Now, like I said, Those of you right now who are still not too sure how to break up this piecewise function, this is the key part. We know that one piece is going to be positive. We know one piece is going to be negative. The hard thing is, what is the domain? And did some of you write this down? Yeah? You did it opposite? Like what? You did like this? Like that? Okay. Which one is it? This is the hardest part, okay? Let's think about this together, all right? Put your pencils down. Good. Let's go ahead and do this again. I'm asking you to find the piecewise function of this. By the way, let's go back to when we started graphing these things out. What did I ask you to graph out first? Ignore the absolute value, so graph out the line. Help me out. Somebody describe this line for me. What's the y-intercept? 3. Thank you. What's the slope? Negative. So it goes downward like this. Well, and this point must be 3. Good. Now, what does the absolute value look like then? Hello? Yeah. Take this part, flip it up. V-shaped graph. Okay. Ladies and gentlemen, you told me this. Seriously, be quiet right now. This is important. Okay. I see 2 parts. Which part does each belong to? 3 minus x is the left side. Because it stays the same. The one that stays the same, no reflection, is the positive side. Stay the same, right? So this should be if x is less than 3. Which part got reflected? The right side. So this should be greater or equal to 3. The part that gets reflected is the one with the negative. Okay? Why is this one different than the one in part B? Because originally inside the absolute value, the sign in front of the x is negative. Okay, I'm getting too excited. So the correct signs are this is less than, this is bigger than or equal to. Okay? Go ahead, dear friends. Let's go ahead and solve, okay? On your own, please. Solve it, solve it, solve it. And if you finish this one, go to the next one. Okay? Show you that this is my algebra. Do we get the same answers, everybody? Uh-huh. Is there anything that's extraneous here? Yeah. Which one? This one, right? -4. Extraneous, because it doesn't belong into the domain. Okay? Now, let me just show you once again visually this, and then afterwards I want you to do 4 and 5 on your own. Okay? Let's go to your graphing calculator, for those of you graphing calculator, and I want you to actually sketch out this graph as well. Okay? Go to the absolute value. Type in 3 minus x. Okay, so please do this if you have your graphing calculator. I want you to do this. And then 2x plus 1. Okay? And I will wait till you get yours typed in first. Okay? Ready, set, let's graph together?
No, wait.
What were you doing?
He was daydreaming.
About who?
Girl, come on, guys. Stop right.
Johnson. No. Okay. Here's my graph. Okay. Now, ladies and gentlemen, can you see why there's only one answer now? Because if you look at the absolute value graph and that line, it only crosses once. Now, just to let you know, Where do you think this other answer, -4, came from? You see this line here? You see this part here? What if I were to reflect it? Or what if I were to reflect, sorry, this part? I know I wouldn't, but if I did. If I were to continue to extend this line, where do you think it's going to intersect?
Right around there.
And what do you think this value is going to be for x? That'll be -4. Okay? Anyways, I just want you to understand that in this case, there's an extraneous root. Make sure you check. You can also check by using your graphing calculator. Ladies and gentlemen, I've actually pretty much taught you how to do every other type of absolute value question now. You should be able to do 5, 4, 5, 6, 7. So we've got about 15 minutes left. You're on your own. Let's see how far you can go. Okay? Go. Number 4. Remember absolute values? What's the smallest the absolute value can be? The smallest this thing could be is 0, right? What's 0 plus 12? So the smallest this whole thing can be is 12. It's supposed to equal 6? No, can't be. So therefore there's no answer. This one's no solution. Now, if you went and did all the cases, you would have found answers, and they would have been both extraneous. What a waste of time. Okay? Now, if you didn't see that so fast, here's another way you could have done this one, okay? Which I think is pretty cool too. If you were to say, well, let's just isolate the absolute value. So 3x plus 5. And if I were to isolate the absolute value, I want to subtract 12 off both sides. What's 6 minus 12? -6. Can the absolute value of anything equal a negative number? That's right. Therefore, no solution. Less than 60 seconds. Done. Okay? All right. Example 5, I believe there are solutions.
Not factor. It is like you have to use it for the other.
So, I'll let you try number 5 right now, and let's see what you get. If you want me to help you out, the piecewise function for absolute x minus 5, that's easy. X minus 5 if x is bigger or equal to 5. Negative x minus 5 if x is less than 5. Go ahead, look at all the different cases. Do you see how I left you lots of room for example number 5? Okay. Go have some fun with this one. Now, notice I've done the replacement of the absolute value, and you get these two equations. They're squares, so I think I'm going to take a look at the one on the right first. This one is factorable, so this I think is just x minus 10x plus 1. So you solve, you get x equals to 10 and x equals to -1. Whereas the one on the right, you can't factor. Oh, sorry, I forgot. Is one of these extraneous? You find out. Okay. Is one of these extraneous? You check. Now, how about the stuff on the left? I can't factor that. So when you can't factor, what do you do? Complete the square. Okay, if you want to. Quadratic formula? You bet. I will use the quadratic formula. Okay, so start to sing the song. Completing the square also should work. Wait, not that fast. X equals to -b. Yeah, plus or minus square root of. Yep.
Oh my.
2b.
2A.
2a. So 7 plus or minus, and let me simplify this, 49, 80, 129. Don't use a calculator, I want exact answer. Ha 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 ha. Okay, now let me tell you. Here, there are actually two answers. One of them is the positive one. Okay, one of them is the negative one. So technically, you got 4 different algebraic answers. 1, 2, 3, 4. I'm going to say to you, for homework, you check to see which one works. And I will tell you that only 2 of them work. Okay? All right, dear friends. May I ask you, please, to try to do some of the section 7.3 homework on the back page. Do as much as you want, because I'll finish this page next day. Don't forget, if you want that bonus mark, Give me a nice solution to that challenge. Have a good weekend, everybody.